Flat Earth, the vector fails, number 3. In this we're going to be looking at the difference between momentum and acceleration. And in consideration to the like the rising Earth, and that's like the force between your feet and all that kind of stuff, so that's like why you've got weight. So in this example, we've got this tanker, you can see the water in it, and when it's accelerating, all the water, it gets, the back pushes against the water, so it all kind of sloshes back. It'll go forward as well, but all that force is like, it's coming from the back in it. So that's like your vector point. So in a sense, like that would be the bottom of the Earth kind of thing, and you'd be able to stand up on there, that way. So so that'd be going up, and so this is showing you how much force it'd need to carry that much water. How much weight or upward force it'd appropriate to carry that kind of thing. So we do an example of like, if this accelerates up to 100 mile an hour, like during that acceleration process, all the water's going to be, have a lot of force coming from back and stuff. But once it reaches 100 mile an hour, it's going to be in momentum, and then all the water will find its equilibrium. It won't need to slosh around to try and re-find its stability kind of thing. So that means that for a rising Earth to be possible, then we'd have to be constantly accelerating, which means that whatever speed we're doing now would have increased by now. And it would increase, I imagine, to be like, like an exponential rate, because it's going to be, because it has to accelerate, it has to be more. And then for you to feel that equal acceleration throughout time, you know what I mean? So you don't even notice it. It just feels like, normal. Right? So then like that acceleration, it has to match up with it all. So it's getting more and more difficult for that to be a reality. You know what I mean? It's like, when did it start? How long's it been going? So how fast are we going now? You know what I mean? If I said we're just going 10 mile an hour now, that sounds quite early. I kind of think that, if you said that 10,000 years ago, then maybe, but it depends how old Earth is. So, if it were 10 mile an hour back then, like 10,000 years, how fast is it going to be going now? You know what I mean? And it can't reset because somebody had noticed. You know what I mean? So it's not happening, is it? And then, like, going back to this, if we were in momentum, then we wouldn't have no weight. You know what I mean? It'd be like a rare occurrence that you can like suddenly feel the weight kind of have to readjust you back into momentum. And so sometimes it's like, you'd be floating off at ground all the time, you know what I mean, and stuff like, and every time the Earth caught up to you, it'd push you again and lift you further up and stuff like that, and once you've had some pressure against you, that's going to push you back up, and you'd leave the Earth, float around for a bit until the Earth caught back up to you. And if it's constantly accelerating, because that wasn't the momentum version, if you're in momentum, you'd be weightless, almost. If you were in constant acceleration, that's the only way that you'd have weight, but you'd have to increase the acceleration, otherwise it wouldn't be acceleration. You see what I mean? So that's like self-contradictory to what it should be, you know what I mean, because we're not experiencing an increase of acceleration all the time and stuff like, my weighing scales should pick that up, unless my weighing scales are affected by the rising Earth. it's acceleration, you know what I mean, and stuff like, because if I'm going to feel the same weight throughout, then I suppose the weighing scales will pick that up. But at the same time, the rise in Earth has to equate for all the different weights that exist. So if somebody weighs like twice my weight, then how does the rise in Earth acceleration balance that out for the person that weighs heavier? You know what I mean? It's gonna like have to rise slower for that person, faster for me. You know what I mean? So suddenly, you know, this acceleration part is it's just a destroyer for what it is, for you know, for the idea of the Earth accelerating. Alternatively, I do see things that settle to the ground. You know what I mean? Like ash, dander, you know, soft light things and stuff like that kind of thing. Compared to like a golf ball, it'll just fall through the air quite simply. You know what I mean? And stuff like it'll make an impact on sand. You know what I mean? Whereas cigarette ash won't. And you can see how it settles to the ground rather than hitting something which is like accelerating. Imagine if you flick cigarette ash into a speeding motorbike. You know what I mean? It'll just destroy it like it does to the bugs on the screen and all these kind of things and stuff like. But yeah, I think that's it for now. Thanks again for watching. I'll see you all later. Cheers.